one unit on laws of exponents. So these are all laws of exponents that you've seen before in probably Algebra 1 and Algebra 2. So this first law right here is when we have two of the same base, and when they're multiplied together, we're going to be adding our exponent, so m plus n. Our second rule here is when we have just one base and then two exponents, so exponent outside of an exponent. This is when you multiply your exponents. So when you divide, we're going to be subtracting, and then this is one where if you have a negative exponent, it just moves to the bottom of the fraction. So whenever you have a negative exponent, it moves from either the numerator to the denominator of a fraction, or from the denominator to the numerator, depending on where it started off with. So it's just changing places in your fraction. And then our last rule here is anything to the power of 0 is always 1. So we're going to be using these laws of exponents to simplify some expressions. So let's start off with number 1. So when we simplify this, so 3 times 4, we already know how to do that. It's just normal multiplication, gives you 12. In this case, we're multiplying a times a to the third. So when you have an a by itself, really the exponent here is 1. So this is a to the power of 1. Since you have two of the same base, we're using the first rule here. So we are going to add together our exponents, so 1 plus 3. And this is going to give us 12 times a to the power of 4, and this is my simplified version. For number 2, we're going to start off with the same thing. So let's first simplify our big number. So this is like any other fraction, 27 over 45. We want to simplify by seeing if there's something we could divide out of both of them. So we're going to start off by dividing, let's see, 27 and 45 are both divisible by 9. So I can divide them both by 9. 27 divided by 9 gives me 3. 45 divided by 9 gives me 5. So I just simplified my fraction. Now I'm going to look at each of my bases. So let's start off with the a's. So I have a to the third divided by a to the fourth. So really what we're trying to do when it's in a fraction like this is cancel things out. So if you have a times a on the top and a times a times a times a in the bottom, we can cancel out 3 of those a's. So if I cancel out 3 a's on top and 3 on the bottom, it leaves me with 1 a on the bottom. Now let's look at our b's. So b to the third, that's the only base with a b, so we're just going to leave it. And now let's look at our c's. So we have c to the fifth divided by c squared, so we can cancel out 2 c's, c squared. If we take out 2 of these c's, we're subtracting 5 minus 2. It leaves us with c to the third. So can't simplify anything else. This is my final answer for number 2. Okay, let's look at number 3 now. So this is when we have an exponent outside of this entire parentheses. What this means is we want to raise every single one of these terms to the third power. So we're going to do negative 3 to the third power, x to the third power, and y squared to the third power. So we want every single one of those to be raised to the third power. So negative 3 to the third power is negative 3 times negative 3 times negative 3. It's going to be negative 27. X to the third stays x to the third, and with this case, see how there's only one base, exponent to an exponent? Here we're going to multiply those. So 2 times 3 gives you 6. Can't simplify anymore. This is my simplified expression. Okay, let's look at number 4 now. So for number 4, we have the same base. We have 2 of the same base. Right, so if we're going to combine it together, this is now, again, my first rule. When you have 2 of the same base, you add your exponents. So we're going to be adding x plus 3 plus x minus 3. And when you add these together, my plus 3 and negative 3 cancel out to give you 0. And then when you add x plus x, that's really just 2x. So a to the 2x is the same thing as our original, just in simplified form. Okay, let's take a look at number 5. So for number 5, this is now where we're starting to have some negative exponents. So whenever you have a negative exponent, to get rid of the negative, we're just moving it to the other side of the fraction. So, for example, this x to the negative 2, because it's negative, I want to rewrite it as a positive. Right now it's in the numerator, and I'm going to put it in the denominator. Now I'm not going to have a negative anymore. Right, so if you move it, you get rid of the negative. This x to the negative 3 was in the denominator, and I wanted to move it to the numerator and get rid of the negative. So that's x to the third up there. Okay, y cubed is already positive, so it's going to stay there. Y squared, already positive, so it doesn't move. Z to the negative 1, because it's negative, we want to move this one, and since it started off in the top, we're going to move it to the bottom. So this is just z to the 1. And now we're going to try to combine our bases again. So we have x to the third divided by x squared. So we can cancel out two x's, right? So x squared and 2 of the 3 x's on top, and that just leaves you with 1 x on top. Y cubed divided by y squared, again, same thing. You can cancel out y squared. When you take away 2 of the y's up here, it's just going to leave you with 1 y. And we're left with a z on the bottom. And since z to the power 1 is the same thing as just z by itself, we don't have to write the 1. This is my simplified form. Okay, let's look at number 6. So this is a 2-part problem. So for this first part, I'm going to first distribute this negative 3. Right, so just like what we did in problem number 3, I want to make sure that x to the negative 1 is being raised to the negative 3, and y squared is being raised to the negative 3. So see how there's only one base, but 2 exponents? This is when I multiply negative 1 times negative 3, it's positive 3. 2 times negative 3 is negative 6. And so now, I'm going to do the rest of this problem. So, see how I have a negative exponent? This is y to the negative 6. I want to make it positive by moving it to the bottom of my fraction, because there's currently nothing in the bottom of my fraction. Same thing over here. X to the third doesn't move because it's already positive. To get rid of this negative, I'm going to move it to the bottom. And now, because they have the same denominator, y to the 6th and y to the 6th, I can just add them together. So 4x to the third plus x to the third, these are like terms. They add together to give me 5x to the third, and I keep the same denominator, which is y to the 6th. And this is my simplified form. Okay, number 7. So for this one, the 3y to the negative 3 is outside the parentheses. So my first step here is going to be distributing this to all 3 terms. So when I distribute, I have 3 times 2 is 6. I have x to the negative 2, y to the negative 3. They're different bases, so I can't combine those. Plus, there's a 3 here, so we have 1x. We have 1y, this is y to the 1. When I multiply y to the negative 3 times y to the 1, so see how there's 2 of the same base. So I'm going to be adding negative 3 plus 1. That gives me negative 2, so I have x, y to the negative 2. Plus the last one, I have 3, y to the negative 3 times y squared. Again, there's 2 bases of y. So since 2 of the same base, I'm going to add my exponents. Negative 3 plus 2 gives me negative 1. So y to the negative 1. And now I'm going to rewrite this. So again, with the negative exponents, I want those to move to the bottom. So 6 stays on top because there's no negative exponent there. So x squared goes to the bottom. Y to the third goes to the bottom. Plus 3. The x stays up there because there's no negative exponent, but y squared moves to the bottom to get rid of that negative. Finally, 3, y to the 1 also moves to the bottom because of that negative 1. So now there's something I can actually do to put these all together using something we learned before, which is our LCD, right? We want to write this one big fraction. So our least common denominator is actually, in this case, x squared, y to the third. So what's missing from each of these? This one's already in least common denominator. What's missing from this one is, so I'm missing an x squared, and if this is y to the third, this is y to the second, so I'm missing one y. So I'm really multiplying everything by x squared times y. This one is missing an x squared, and I want it to be y to the third, so I'm missing 2 y's. So I'm multiplying everything here by x squared, y squared. So this gives me now an entire fraction where all the denominators are now x squared, y cubed, because that's what all these denominators are. And what that leaves me with on top is I have 6 plus 3, so this is 1x times x squared is x to the third, y, plus 3 x squared, y squared. So those are just all my numerators, and this is my final simplified version written as one fraction. Okay, for number 8. So we're going to start off again by rewriting these negative exponents. So x to the negative 2 is the same thing as 1 over x squared, because again we're moving it to the bottom, minus x squared over, this is 1 over x to the 1, so we're just getting rid of all of our negative exponents. And this is another blast from the past with our LCD again. So look at our denominators, we have an x squared and an x, so our least common denominator is x squared. What we want to do here, because it's a fraction inside of a fraction, we want to multiply everything by our LCD. So this is going to be multiplied by our LCD, this will, and this will. Everything is being multiplied by our LCD, which is x squared. When we do that, this x squared and this x squared cancel out, this leaves you with 1. Minus x squared times x squared, so two of the same base, we're adding together 2 plus 2, so x to the 4th. In this case, x squared over x to the 1, so one of these x's cancel out to just give you x, minus x times x squared, so this is x to the 1 times x squared, which is x cubed. And this is now my simplified version. So number 9 is very, very similar to number 8, where again we're going to first rewrite with our negatives at the bottom. So in this case, x stays on top, y goes to the bottom, y to the 1. Over here, this is 1 over y to the 1 again, minus 1 over x. So again, all of your negative exponents move to the bottom because they were on top. And now we're looking at our LCD. So our LCD is, we have an x and a y. We want to multiply everything by xy. And what this leaves us with is we have an xy on top minus the y's cancel out in this one, which leaves us x times x, which is x squared. On the bottom, our y's cancel out, which gives us x times 1, which is x, minus our x's cancel out, 1 times y is just y. There's my simplified form. Last problem, so for number 10, again, these negative exponents means this is going to be 1 over, and then 1 over. Alright, so these are two separate terms because of that plus sign in between, so we actually cannot distribute this. You can only distribute this when they're being multiplied, so an exponent. So what we're first going to need to do is, just like we were doing before, is figure out our LCD. So we need them to both have an a and a b in it. So this side is missing the b, this side is missing the a. So this is going to give me a denominator of a times b. Up here it's b plus 1 times a is a. And now this whole thing is being raised to the negative 1 power. So being raised to the negative 1 power just means that the whole thing is negative. So I'm going to switch the signs, or the sides of both of them. A and b used to be on the bottom, now it's on top. B plus a used to be at the top, now it's on the bottom. To get rid of that negative, but for both of them, they're just going to switch from numerator to denominator, denominator to numerator. There's my number 10.